Hello, my name is Kyle Mulca, and I will be your instructor today. Um, I actually I wasn't able to record the session, um, but I'm going to do a recap. It'll probably be a little faster than I did it during the actual session, but feel free to pause or rewind if you need any extra help. Um, or you can send me an email. Kyle@kylemulka.com is my email address, MULKA. And this session, the Python Lab for DC Python, happened on March 8th, 2020. All right, so the first thing we did is make sure that everybody had Python installed and running. So a couple of things I'm going to do for that is um, there's a couple ways you can install it. The way that I would recommend is through Anaconda. Anaconda. Oops, I spelled that wrong. Anaconda. So you go to anaconda.com, and up here on the top right, there's a download link. This is taking forever to load. Interesting. All right, there's a download link. Yes, I want to download. You'll want the 3 version of Python. In this case, it's 3.7, but you'll probably want at least 3.6, if not 3.7, or if it's available, even 3.8 will probably work. Um, Old stuff will use 2.7, but I don't recommend starting with that. So please use the 3 version. So we're going to download. Let's see if this actually works. If this doesn't work on my computer, then I'll try something else. But okay, that might take a little while to download. The other thing that we need is a code editor. Um, so I actually prefer Sublime Text. Um, Actually, in my day-to-day job, I use this thing called PyCharm. Um, and I actually use the Pro version, but you have to pay for the Pro version, so it might be easier to just use a simpler version like Sublime Text. There's also Atom. I actually used Atom during the class. It was actually pretty simple to get started with. There's a bunch of different versions. I'm on a Mac right now, but there's also a version for Windows. Um, Same thing with all these. Like all these have a Windows and a Mac version. Um, if not a Linux version as well. Let's see. So download one of these. During this video, I'm going to be using Sublime Text. So I already have Sublime Text downloaded here. Um, what we're actually going to do is we're going to create a folder to have all of our Python files in. And I will show you how to do that in a second. Let's see if this is downloaded yet. No, it's not. Okay. So Python or Anaconda is the easiest way to install Python, but there are other ways. And um, one of the ways you can just go to python.org and download it. So python.org downloads. Python 3.8 is good. You can do it that way. I probably won't go through that. I won't actually show you how to do that, but if you have any questions about this, feel free to shoot me an email. All right. So let's assume we already have Python. And I actually already have Python in my terminal here. Um, so we're going to be using this text editor, in my case Sublime Text, but whatever IDE you use is fine. Um, I did mention that um, Jupyter Notebooks is okay to use for most stuff. I was thinking about doing some stuff on the command line, um, so that may or may not work in Jupyter Notebooks, I'm not sure, but for the most part you can use Jupyter Notebooks for most of this tutorial. Okay, so this is our terminal that we're using. So on Mac, I'm using iTerm here, but you can just use the regular built-in terminal. on Mac. So if you search terminal, um, open that, that'll be almost exactly the same as what I'm using. There's just a couple extra features with iTerm2. On Windows, you're probably going to want to use the Anaconda PowerShell. So that's Anaconda PowerShell. So you'll search for that in the Windows menu. So the Windows menu will be like down here, and search for that and open it, and that will work similarly to what we see here with the Mac terminal. Okay, so the first thing we're going to want to do is get Python working. So what I recommend is typing Python and just pressing enter. So I typed Python and then I press enter in the terminal. This is also called a shell or a command prompt or command line. Those are all basically the same thing. I might even use them interchangeably here. This is my terminal app. So I typed Python and I'm getting all this stuff. So actually the first thing it says is Python 2.7 is not recommended. It is no longer supported, and I definitely would recommend you use 3 point something, 3.6, 3.7, 3.8, something like that. The code we're going to use is probably not going to be different between 3.6, 3.7, and 3.8, but it will be different from 2, so please use 3. Okay, so instead is it recommended that you transition to using Python 3. Um, if you have 3.7 installed and it says 3.7 here, that's fine to keep using this. But because my Python says 2.7, I'm going to use 3 instead. So to get out of this Python shell, so right here, we were in the operating system shell, and when we type Python, now this thing right here is the Python shell. And you'll notice it looks different. Like this looks different than this. That's how you can kind of tell them apart. So these 3 things are the Python shell, and then this is your operating system shell. And this might look different if you're on, Windows or, um, and actually it even includes like my username here, and then I think this is my host name or something. And then this is the directory I'm currently in. Currently I'm in my home directory, which stands for the tilde right there, that little squiggly sign. It's going to be in the upper left of your keyboard. You'll probably have to use shift to get to it. But let's exit out of the Python shell. I'm going to exit out of the Python shell. If you type exit, actually it'll say instead of using that, use exit with parentheses, or in my case it says Control D. I notice in Windows it says Control Z, but whatever it says there, it's fine to use. In my case, I'm just going to say exit, and then I'm going to call this exit function by using the parentheses. So call the exit function, and that gets you out of the Python shell. So I'm going to use Python 3. So instead of typing Python on the command line, type Python 3. And now here I have Python 3.8.2. Perfect. So out of that again. All right, let's see. What can we tell you about this thing? So I'm going to basically show you 2 different ways of accessing Python. One is via this Python shell here, and then after we get comfortable a little bit with how this works, then we're going to switch to using files instead, using this IDE. So first we're just going to kind of use this terminal to show off some features of Python. And these features of Python will work with files, um, and but there's one main difference. So if you here, let's say run Python 3, and then let's do a simple command like 2 plus 2. And do feel free to follow along. If I'm moving too fast, feel free to stop the video at any time. Rewind or whatever. Okay, so 2 plus 2 is equal to 4, obviously. 5 times 5. And it actually doesn't necessarily matter if there's spaces here. Um, it is common style to have spaces between your operator. It just looks a little cleaner. But to the Python interpreter, it doesn't matter exactly. It usually matters just if you're keeping with the Python style. Okay, so these are called integers that I'm using here. We have 4 and 25. There's also what are called floating point numbers. So if I do like 5 divided by 3, I get 1.6 repeating, and then there's a random 7 at the end. Computers don't actually store like these infinite repeating numbers. They have to like cut off at some point, and so it's basically rounded at the end here, which may sometimes give you funny math. If you're using floating point numbers, they may not give you exactly what you're expecting. Um, maybe you're expecting a 2, but you get like 1.999999 or something. So just be careful about that. All right, so that's a few commands there. Um, so let's do a little hello world. Um, so I'll need out of that. And then over here in my text editor, I actually need to, what else I need to? Okay, so we're going to create a directory. So I got out of the Python shell, and then in the operating system shell here, I typed ls, and that stands for like list directory contents, I guess. So it just lists like the folders and the files that I have in this directory. This happens to be my home directory, indicated by the tilde. You can actually figure out where you are specifically if you type pwd, stands for print working directory. In my case, I'm at user/live streaming. This is the username that I'm using my computer right now. Let's see what else. Okay, so we're going to create a code folder. So I actually have this code folder on my desktop, or sorry, in my home directory right now. That's kind of where I keep stuff, but you can feel free to put um, this directory wherever you want, whether it's in documents or on your desktop or whatever. So I'm going to go into code, and then, so the CD stands for change directory. So what I did is um, I was in my home directory. Now I'm going into this code directory here, and I can see what's in here. Right now it's just this one folder called TweetStream. I'm going to make a new directory, and I'm going to call it Python underscore class. Do make sure that you name this the same as me so we kind of are on the same page here. Okay, so make dir Python class, and then we're going to cd into that directory. You'll notice I pressed well, I did press the tab key to get there. Again, if you, here, let's go up one directory. And to do that, use the dot dot. So cd space dot dot. So we just went up one directory back to our code directory. And now if we do an ls, we'll see that we have this folder here. And this is, you can also create this directory in your, the way you normally create directories if you want. It doesn't, you don't have to create it here if you don't want to. This mkdir is like make directory command. But in the file system here, I have my code folder, and then I have my folder here. But instead of doing it in here, I could have just, created a new folder. Um, so, oh, so when you do cd space, and then you want to go into one of these directories, you can just start typing the directory name, like maybe one or two characters, and then you press the tab key, and it'll automatically complete the rest of it if it knows what it is. So if there's only one folder that starts with py, it'll just fill that in for you. If there's multiple folders that start with py, you can just press, you just keep pressing tab until you get to it, and just cycle through them. All right, so we're in the Python class directory. And what I'm going to do is, now that we have a directory, I'm going to open that directory in my editor. So in my Sublime Text, I'm going to say File, Open. I'm going to go in my code folder, and then I'm just going to click on the directory here, to a Python class. So open. What this does is it allows me to see what files are in this folder. Right now there's nothing, but when we start making files, they'll show up here, which is nice. So we're going to create a new file in this folder, and this time I'm going to do it with Sublime Text. I'm going to right click on this. There might be other ways to do this, like File, New File, or whatever, and we save it. And I'm going to do this, right click, New File. Oh, it doesn't even save it yet. Okay, so I'm going to save this. The shortcut for me is Command S, maybe Control S on Windows, or whatever your IDE supports. Maybe, you have to file save or something. But save it. We're going to save it as hello.py or hello.py here. Save. Okay. Now if we do ls, we can see this hello.py. And inside this hello.py, we're going to write print, and inside of here, we're going to say hello world. You'll notice these open and close quotes. So we're calling the print function, and we're passing it this thing that is called a string. The string starts with a single quote and ends with a single quote. You could use double quotes here if you wanted to, like this. I prefer single quotes, but Python doesn't care which one's which, as long as the first thing is the same as the last thing. One reason you might want to use one or the other is if you have something in the middle. So if you wanted to include a single quote in a single quoted string, this wouldn't work because Python thinks that the string ends here, and it doesn't really know what to do with this rest of the stuff. But if you were to use a double quoted string, you could put a single quote in there and it would actually work. Same thing, vice versa. So if you did a single quote on the outside, you could do a double quote on the inside. But you couldn't do like a double quote with a double quote, if that makes any sense. You'll notice my editor color codes this stuff, and these are actually different colors because it knows that yellow is a string and white is not a string. It's like outside the string. But all right, we're just gonna go back to my single quotes, which is what I prefer. Okay, so hello world, and that's it actually for this this um, program. this is a valid Python program. You don't need any other sort of text in this file. Um, this is it. That's a Python script. The way that you would run this, the way that you would execute this is in the terminal, you type Python um, and then the name of the file. So hello.py. Um, so I was using Python 3, so I'm going to continue using that. So instead of Python here, I'm going to actually need to use Python 3, but you may be able to just get away with using just Python if you have Python 3 as your only thing. There's different ways to install Python and might depend on your environment. So I ran hello.py. It printed hello world here um, without the quotes, not the single quotes. So that's great. So that's our first hello world. We're going to expand on this a little bit, and we're going to say hello instead of world. We're going to say hello. We're going to put your name in here. So for me, that would be Kyle, but feel free to put your own name in there. And if you save that, save the file, and then rerun this, now it says hello Kyle. Cool. Um, the other thing we can do is we can basically, instead of modifying our code here, we can pull out this string into what's called a variable and allow us to pull that variable from other places. Um, so that might be the command line or a web application or a database. Pull it from somewhere else. But right now, we're not going to pull it that far away. We're actually just going to pull it into a variable called name. So name equals that. Equal sign in here indicates that we're assigning a variable. So we take the string Kyle, which is just stands for a string of characters, I think. Um, but a lot of programming languages have that. So a string of characters, and we're assigning it to this name variable. Okay? And then inside of here, instead of hard coding this on this line, um, we're going to separate this into two strings like this. And then we're going to add a couple plus signs in here and put the name variable inside in between those. So we have hello space and then name and then exclamation point. So the name is a variable and then these are just strings. In this case, this is a string as well, but we're putting it between these two other strings. This is called concatenation. So you're concatenating, I don't know why it's called concatenation, but you're concatenating multiple strings. You're basically stringing strings together. Um, and so let's save this and run it, make sure it does the same thing. It does, in fact, do the same thing, which is good. So here I could change this and say, hi, Sally. Save that, run it again. It says, hi, Sally. Or, well, hello, Sally. Okay, so what if I wanted to say hello to two people? I could copy this code. This is one way to do it. I could copy the code, and I could just change this name. So maybe I want to say, hi, Kyle, and hi, Sally, like that. I could run that, and that would work. That's one way to do it. But the problem with this is that if later I wanted to change the word that I use here, like hello, for example, I wanted to change to hi. Maybe I wanted to say hi, like I wanted a short version. If I only change one of them, it would only affect one of them. but maybe I wanted to do both of them. So I'd have to like go in and do both of them. Oh geez. Every once in a while, Sublime Text is gonna prompt me to buy it, um, but that's okay. Um, Sublime Text actually will keep on working for you even if you don't buy it, um, but it just gets annoying if you're saving a lot. Okay, so all right, so I updated it in two places, and you can imagine, if you had to do this multiple times, you'd be like, copying and pasting, and then have to change this a bunch of times, and be annoying. So what we're going to do is we're going to show you a way to not have to edit multiple places. We're going to have this in one place, basically this section of code in one place, and then only have to modify it once. So, for example, let's go back to hello. Um, we still want to do Kyle and Sally, but we're going to move this up and put it inside of a function. This is how you would define a function. And then this is how you would call the function. Just to make this a little shorter, I'm just going to forgo creating these variables here and just put the names inside here instead. Okay, so what did we do here? So here we defined a function. Def basically stands for define. Hello is the name of your function. This could be anything really. This is a variable that you're passing in to the function. So when you put this string here, inside this function it gets assigned to this temporary name variable. This name variable is only accessible within the function. Within the function meaning right now just this one line of code. So this is like within the function. Python is space sensitive, so you'll notice that I indented this line of code. And that basically indicates that this line of code is inside the function, and these two lines are not inside the function because they're not indented. You also have to make sure that you have this colon at the end of the def line, whereas these other lines do not have colons. The other place that you might have a colon is if, so there's other places that you might have this colon, and that would be, there's a thing called a for loop, which might look something like this. Oops, sorry. Or a if, like that. Um, we actually won't go into for today, but I will talk about if loops, or sorry, if statements and these if blocks. Okay, so for this indentation is actually important. Um, I used the tab key here to do this indentation, but actually I think down here if you look it says tab size 4. Your editor might be configurable. You might be able to change the size of the tab, um, or you might be able to use this option called indent with spaces. Um, for me, I usually indent with spaces, and usually the tab width is 4. So I'm going to turn that on. So indent with spaces, and there's going to be 4 spaces. So I'm going to remove that tab and tab again, and what that did is it replaced this with four spaces. And so now I can go back and forth one space at a time. So the recommended way in Python to do this is to use four spaces, but you can configure your IDE to automatically put four spaces if you press tab. Um, but it is your option to change this if you want. Like some people like two spaces instead, um, or just use the regular tab character, in which case this will all be one thing instead of four separate spaces. As long as you're consistent within a file, um, you should be okay. Um, but just keep an eye on that because that's pretty important. It'll give you an error if you don't do it that way. Okay, so we got functions. We're calling the function. Just test it again. Run the thing again. What else did we talk about? We talked about types. So these are string types. Um, we also have integer types. So for example, I'm just gonna put that up there, and then if we define a variable, maybe called myvar, and we say myvar equals to 1, and then we're going to test to see what the type of this variable is. So if I were to print the type of the variable, I would do this. So print is a function, type is a function, and then this is my variable. So variable equals 1 currently. So type is going to return, it's going to give me the type, and then the name of the type, and then print is going to print that name. So it's not going to print the variable, it's going to print the type of the variable in this case. So let's just run that. In this case, so we have the hello stuff, and then it says class int. Int in this case stands for integer. It's just a regular whole number with no fraction. There's also a float type. So if we were to change this to say 1.5, rerun this, we get a float type. So this is our floating point number that I was talking about earlier. It's just any number that has like a decimal point in it, basically. There's also strings. So if instead my var is, Kyle, then we rerun this and we get str. So str stands for string, and yeah, so those are kind of three main types in Python. There's also Boolean, like true and false. We run this, we have a Boolean, so this is bool. There's the none type, which is sort of like a generic way to say there's nothing here. um, nothing here to see. Just a good way to represent that there's, it's not a valid value or something. And actually, you know what, if I call this hello, I haven't really explained how return types work here, but if I call this hello function, you'll notice that it just prints, and there is no return statement. A return statement look like something like this, like return, something, right? But if I leave that out and I call hello, It does require this name thing right now, so I'm going to say, I'm just going to put Kyle there again. Um, and I basically I call this function and then I set the result of that function to this myvar, and then I check the type of that here. I believe the type of that is going to be none. Yeah. So I save this and then I reran it. Um, the return type is none, basically saying there's no return function in here. Or there's no return statement, I should say. But if we were to say return something, maybe maybe instead of printing this, we return it. Um, and the return statement does not have parentheses, so I'm going to remove those and just put a space here. Um, so functions need parentheses and statements do not need parentheses. In Python 3, print is a function. In Python 2, it was a statement, so it did not need parentheses. But since we're only using Python 3 now, print is a function, and return is a statement. Okay. So now what we're doing is we're returning this instead of printing it. So one thing you'll notice is that when we run this, you might want to stop the video and think about exactly what might happen here now that I'm returning it instead of printing it. Like what is actually going to be printed here when I run this code. Okay, so now stop the video if you haven't. I'm going to run it. Okay. So I run the function now, or run the script rather. The only thing that's printed is class str. So what happened? Why didn't we print these things? Well, because there's no print function anymore. We don't actually print these. And furthermore, when you're in this script mode, you're basically running a Python script from a file. It doesn't print every line like the Python shell does. You'll notice every time we did something here in the Python shell, it printed something, right? Like if we just did 2 plus 2, it'll print 4. But if we put, 2 plus 2 in this file, it won't actually print this. This is actually called a read eval print loop, or REPL for short, REPL. It So, this is a REPL and it reads basically one line at a time or one section at a time. It evaluates this. So in this case, it's going to be 4. It prints this, prints the 4, and then it loops. Basically, it does the same thing. So it reads the next line, evaluates it, prints it, reads the next line, evaluates, prints it. That's the read eval print loop. But a regular Python script doesn't have that. It just, reads every line, evaluates it, and even if it has a return value, it doesn't print it. So if we wanted to print these things, we could, but we'd have to wrap them in the print function here. Or assign them to a variable and then print them later, or whatever. So I've just printed two things here, print, and we run this. Oh, wait. Oh, I didn't save the file. Gotta make sure to save the file. In Sublime Text, there's this little indication, this little circle that indicates that the file is not saved. Like I changed the file, but I didn't save it, so I have to save it here. So I'm going to do Control S to save it, and then this actually turns into an X to close the file. Okay, save, rerun. Okay, so now it prints two things. Print, and then here, instead of printing, it's just assigning this variable, and then we're printing the type of the variable. So the return type of this is a string. So this thing is a string. Okay, so now we know how to check types and stuff. We're going to do an if statement. So if type of my var equals int, then print. I'm just going to do this real quick. I just do this and I'll explain what I'm doing here. Okay. So this is an if statement. Um, you have the if section here, and you actually have an else section. This else section is optional, actually. I could have just left it at this. But if you have an else section, uh, it'll do one of two things. Or sorry, it'll do one, yeah. It'll do either this section of code or this section of code, depending on what this evaluates to. So this thing, type, so it's taking the type of my var, and then this is a comparison operator, the equals operator basically. It's actually two equal sign. The reason it's two equal sign here is because we already used the single equal sign is used for assignment. So we're assigning this value to this variable. Um, but that's not what we want to do here. We don't want to take this and assign it to that. That wouldn't even make sense. Um, we want to compare it. So we need to use the double equal sign here in Python. Okay, so if it's an integer, print integer. So if we save this and run it, let's see what happens. So at the end here, it's actually print unknown. So it's not an integer, so, well, we don't really know what it is right now. In this case, it happens to be a string, but you can reassign these variables. I'm just going to reassign this down here instead to make it an integer. The other thing I talked about is, so I have a lot of code here, and every time I run this, it's like printing out everything. But if I didn't want that to do that, if I didn't want it to do that, I could tell Python to ignore this stuff. The way that I would do that is to um, put the pound sign at the beginning of the line. And you'll notice it actually changed color in my IDE to like gray. Another way to do that is to just highlight everything that you want to comment um, and do a mine, it's command forward slash. Might be control forward slash or something else for you. Um, it's also in the menu here somewhere, I think. Yeah, it's like edit, comment. Yeah, so this is command forward slash for me, or shift command, toggle block comment. That might be something else. But yeah, I just selected the whole thing and I pressed command forward slash. Yeah, so this will now ignore everything here. So if I rerun this, it'll just do the section that I haven't commented yet. The reason you might want to comment, a couple reasons. So this is one good reason, is if you have code that you don't want to run, but maybe you want to save for later. Maybe it'll be useful in the future. You might want to leave it there. The other reason is to just explain kind of to yourself in the future or to other programmers, like kind of what you're doing with the code in case the code isn't clear what it's doing. So here, this is kind of a simple example, but um, maybe I'm, checking the type or something. I don't know. Yeah. Okay. Python 3 hello.py. That is now an integer. So this is now an integer of type int. If I did like, my var equals 1.5 instead, that would be a different type. It's actually the float type, but we don't have a check for float here, so it says unknown. If we wanted to add another check here, so we're already checking for integer, but if you wanted to check for something else and actually, print float or floating point instead of integer, we could use what's called an elif, or short for else if, and do something similar like this. And then print, this is a float. Um, so now I have 3 sections of my if thing, and only one of them will be run, either this one, or this one. And it goes in order, so if this is true, then it'll print this. If it's not true, then it'll check this, and if it's true, then it'll go there. If this isn't true, then it'll go to the third thing, the last thing here. And you can actually continue to put these things, these elifs, in the middle here. Usually the else is at the very end. Actually, I think that's how you have to have it. So the else is at the very end. If none of the things is true, then it does the else. Okay. Another thing you can do, okay, so I have the elif. Okay, so that's going to run, I'm going to say float. I'm going to put another elif here and do a string. So I just copy pasted those 2 lines of code. I'll say if my var is a string, then print string. It is not a string currently, so I need to make it a string. Hello there. So that's going to be a string. Okay, so it says string now. One thing you can do is you can basically, what do they call this? You can put one if statement inside of another. So we have this outer if, and then inside you could say, if my var is equal to, not the type of my var, but if my var itself is equal to something like, Kyle, then print, hey, that's me. I have to use the double quotes here, but because I put a single quote in there. Hey, that's me. Save that, run it. So you'll notice that checked this, that was not true. It checked that, that was not true. It checked this, that was true, so it printed string. And then it says if my var equals Kyle, that is not true, so it actually skipped this. It did not print this. And then it also skipped this else because this elif was true. So it didn't go to this one. So that's that. And then if I change this to Kyle, you could think about what this might print. If I play that. So it's a string, and since it's Kyle, it says, hey, that's me. Cool. That's an if statement. Let's see, what else did we do? Okay, so we've used this function a lot, or we've used this file a lot. Let's create a new file. New file, and we're going to call it hello2.py. In hello2.py, so one of the things we want to do is we want to take input from this command line. So we've been running this script, and it's just been outputting stuff. But we can also take input. Um, so in order to take input, we just literally call the input function, and we store the result of that function in a variable. So let's say name, and then we'll print name. Okay, so now if we were to run this, remember we have a new file, so we have to change the name of the file in the command line here. Oh, and by the way, I've just been pressing up to get to these other things. You press up and then press return. Hopefully you weren't typing that every time. Sorry about that. Python 3 hello2.py. There we go. You'll notice that this is a little different than we've run it before, because even though I pressed enter or return, it didn't come back with anything, and it didn't return me to this regular command prompt. What it's actually doing here is it's waiting for me to type something else. And that's what this input function does. So I can type something. In this case, it's looking for a name. So I can type my name here and then press enter. And what it did is I typed my name once. It stored it in this variable here, and then it just printed it back out. So you end up with two things, two names here. One that you typed and then one that it typed. The other thing you can do is you can add a prompt to this input. You can add a string, and you can say, what is your name? Ew, this big ugly pink thing showed up. That just means I haven't closed the string yet. It's confused about what's going on here. So let's end that. What is your name? Oh, question mark. I like to do that. What is your name? Question mark. Let's rerun that script. It says, what is your name? Question mark, and then it puts the cursor immediately after the question mark. So you could type Kyle, and it would do kind of what you would expect. I like to have a space here, so I like to put the space in, just to have a little space before you type something. All right. So I'm just printing name right now, but really what I want to do is I want to do the same thing we were doing before and say hello name and exclamation point. So one thing I could do is I could just take this code from the previous exercise and put it here. And that would work just fine. Just test it out here. Hello, Kyle. But what I really would like to do is I don't want to, copy paste it again. I mean, I already did it here. Like, can I just call this function from this other file? And the answer is yes. Yes, you can. So the way that I would do this is I would uncomment this. So now we just have this uncommented, and the rest of the function is commented. Or sorry, the rest of the script is commented. And we can call this function from this other file. So let's go ahead and do that. So instead of doing this, Um, that function I called, it was called hello, so I'm going to say hello, and then I'm going to pass the variable name. So that should work, right? Okay, so what is your name? Kyle. Enter. All right, so we have an error message. This is a good time to teach you a little bit about error messages in Python. It didn't do what we wanted, and I can tell you why in a second, but first I want to show you this little thing, this traceback. So it basically tells you kind of where in the program it screwed up and like sort of like why it screwed up. It tries, you know. So it says file hello2.py, which is this file, line 2. So good thing our IDE shows us line numbers. If your IDE doesn't do that, I would highly suggest you either switch to one that does or enable it somehow. In module, I don't know exactly what that means, but this is the actual line, line 2. This is just the constants of this line. And then it says name error. Name hello is not defined. What that means is that we didn't define this function in this file. So this file doesn't know about that other function because it's not, it's not the same file. So what we're going to do is we're going to tell it where this function is. So at the top of our hello2.py, we're going to say, actually to make this a little bit easier, I'm going to rename this function. So instead of hello, we're going to say hello world instead. And we're going to use that same name to reference it over here. So you need this to match up, basically. So we're going to say from hello import hello underscore world. So what this means is that it's looking in the hello.py file for something called hello world. In this case, it's a function, but it could be a class, which I haven't taught you about yet, but or a variable or something. So yeah. The other way to do this, which is a little less wordy up here, so instead of that, you might do import hello. So that basically imports the entire module. In this case, it's hello.py, and you need to prefix anything that you're using with the hello module. So down here would have to be hello dot hello world. So you have the hello file, and then you have the hello function, hello world function. So inside this module, you have this function, and you use the dot notation here to indicate that this thing is in this other thing. Okay. Nope. Oops. But I'm going to go back to this other way of doing this because it's shorter here, I think. I usually prefer to specify it this way. Unless like these names conflict or something. Like if you have, two hello world functions and they act differently. All right, so now this should work. Yes, so I'm literally using this function in the other file. And so if I wanted to change how this worked, you could just go in here and you could change how this function works. And then if you rerun this, it'll automatically change for you like that. Okay. So let's move on. This is my little notes for what I taught. We talked about math in the Python shell. We did a little bit of command line stuff. Um, talked about types. We talked about strings, functions, if statements. Um, yeah, so now you know kind of the basics of Python. We haven't really talked about loops yet. I didn't actually cover it in class, so I guess I won't do it here. But that might be something you could do on for homework. Look up how to do for loops. So Python can be used for a bunch of different things. Um, so you could use it for web application development. Um, you could use packages called Django or Flask. Those are two popular web application frameworks. Um, I'll go ahead and show you those. At least show you the websites for them. So Django, spelled like this. Um, and then Flask is another one. So Flask is a little bit easier to learn than Django, but Django is more complete. So if you're doing kind of a full-fledged web app, you might want to use Django. Um, if you're doing something simpler and you don't want a lot of the either learning curve or the extra things that Django includes, you might consider Flask. Personally, I prefer Django and most stuff that I build. If I'm building like a web application, I'd probably prefer Django. I think the ORM is a little nicer, like the thing that you interact with databases with. Um, but it does take a little time to learn. Um, I do recommend if you look at the documentation here, the tutorial is pretty nice. So if you go through the Django tutorial, that will get you set up with Django. There are also other tutorials online about Django, which are more complete, that cover more stuff. Um, like, for example, Django Girls. Um, if you look at the Django Girls tutorial, um, it covers more things. Like, it actually covers like the command line, some of which I've covered here. Um, and it also covers things like HTML, CSS. Um, it covers a lot of stuff, and personally, I think this is like too much stuff just to get started, but depends on your learning style. If you'd rather get like, everything in one go, or if you kind of want to do just the Django stuff, just the Python stuff, and then, take different tutorials to do the HTML, CSS, and stuff. If you're doing like front end web development. Um, all right, there's um, also a couple other things. So data science. So Python is used for data science a lot. Some people use R, or there's a couple other things you can use, but Python for data science. Um, One popular Python package is called Pandas. And I'll actually do a little bit of Pandas right now, um, hopefully soon. Okay, Pandas. I'll talk more about Pandas later, so I'm not going to cover it right now. There's also TensorFlow um, and PyTorch. TensorFlow. Oh, that's annoying. What the heck? GitHub. Hmm. Anyway, both TensorFlow and PyTorch are used for what's called deep learning, um, which is a subset of machine learning, which is itself a subset of artificial intelligence, or AI. Um, there's another package called scikit-learn. Scikit-learn. Scikit-learn is used for machine learning, but it doesn't really cover deep learning. So deep learning is where you'd have what's called a neural network, and you might be able to do like image recognition or image classification or natural language processing. Um, if you're doing natural language processing or NLP, there's actually another library you can use, a package called NLTK. Um, but anyway, these are getting pretty specific, and so if you're interested in this stuff, like after you learn the basics of Python, which you actually might be able to pick up enough in this exercise um, to start, playing around with these things. But you'll want to kind of do a tutorial in one of these um, other Python packages. I actually use TensorFlow in my day job. If you're going to use TensorFlow, I would recommend um, this thing called Keras. So let's see, I think if you get started, if you're getting started with TensorFlow, just quickly, yeah, so this thing called Keras, Keras, um, that is probably what you want to use to get started with this tf.keras. I'd recommend using, TensorFlow 2.0 with Keras. There's this thing called Google Colab, which we talked a little bit about, which is like Jupyter notebooks in the browser. Um, and so if you're using Colab, you want to specify tensor 2 point something. Um, and again, okay, so this is actually not a Python thing. This is sort of like a Colab thing here. You wouldn't be able to do this if you were just using Python, but you're specifying a specific version. If you were to do this in regular Python, you just install TensorFlow, and you'd probably get the latest version. If you don't have the latest version, you can upgrade to TensorFlow 2. Um, but this just like selects it in Colab, and then there's a bunch of tutorial stuff here. Okay, back to Pandas. Um, okay, so Pandas. What is Pandas good for? Um, data science. So we're going to create a new file, and we're going to call it data science. So data underscore science dot py. And in this file, let's see if I can actually do this here. Let's see. Um, we're going to import pandas as PD. PD stands for pandas, and it's a um, common way to do this within the data science community. They commonly use shortcuts like this, like PD instead of typing pandas every time they want to use it. Um, so I'm just going to see if this works. Python 3 data science.py, no module named pandas. Okay, so I think, hopefully I can pip install this. So pip, the Python package installer, if you're using Conda, if you're using Anaconda, um, you'll want to do conda space install space pandas. Um, I'm not going to actually run that. I don't think. Oh, sorry. Did I? I think it still has two L's. Um, what I'm going to do instead is do pip install. So let's see if this works. Pip install pandas. S or sorry. Um, I so if you're using so here if you're using just Python instead of Python 3, this is what you'd want to do. If you're using Python 3 here, like the Python 3 command instead of, I mean everybody's using Python 3, but if you're using this command, you want to do pip 3 instead. Um, so I'm going to do pip3 install pandas because it wasn't found. Okay, so that will take a little time. Um, in the meantime, I'm just going to minimize that to make it not so distracting. I'm going to create what's called a CSV file. Um, so create a new file, save it as data.csv, and put some data in here. So our first row is going to be a header row, and it's just going to specify the columns that we have. This is basically, it's a spreadsheet. We have two columns, name, comma, age, and we have three people here. So Frank is 18. Um, I don't know. Jerry, or sorry, what did I do? Sally is, I don't know, 35. And Richard is 67. I don't know. I basically just came up with these randomly, but um, basically you want ages that are integers, just whole numbers, and you want kind of one under, I don't know, just call it 18, and then maybe a couple more that are older. Okay, so this is a simple data file. If you're actually working in the real world, you'll probably have more rows and more columns in your data file. But this is just kind of for demonstration purposes. So we're going to switch over back to our data science.py file. And we can still type stuff while this is installing. Actually, let's see if it's done. Yeah, okay. Um, so looks like this succeeded. If this didn't work for you, just shoot me an email and, paste the error message in so I can see what's going on. And I'll help you out. Python 3 data science. That sits for a little bit. It takes a second. Um, and actually, I think the next time you run it, yeah, it's even faster the next time. I think that's because it um, is compiling the files. Um, even though Python is an interpreted language, it still kind of saves some speed by um, doing this kind of bytecode compilation step ahead of time. And if you don't change some of your source code, it'll run a little faster the next time you run it. And actually, you'll notice that we have another folder here called PyCache. Um, oh, I guess there's nothing in there. Let's see. Find it folder. Nope. I swore that there should have been something in there. Oh yeah, there is. Okay. Um, hello.cpython38.pyc. I think my ID is just hiding this file because it's a .pyc file, but this is like the compiled Python file, and you probably won't be able to read this in a regular editor. Um, I would just, basically ignore this directory. Um, Sometimes if you're getting weird stuff happening, deleting this directory and then rerunning your Python command might help, but that's pretty rare. Um, okay, so pandas. Let's do um, pd.read CSV and then give it the name of the CSV. And then we're gonna assign this to a variable called df. Df stands for data frame, and it's basically the type of object that read CSV gives you. It's the main type of object that you deal with in Pandas. Um, Here we're just going to print it just to see what's in it. So we're reading this CSV that we created, and then we're just printing it. So let's see what that is. You'll notice that this CSV just has a comma in between these things. This format is a little different. Pandas actually understood the CSV format and created multiple columns here for us. It also numbered these rows. So it started at 0, 0, 1, 2. So there's a couple things we can do. Um, One of the things you might want to do is, okay, so when you print it, Pandas will by default only print so many of these rows. I don't remember what the limit is, but it's certainly more than 3. So right now it's just printing all the rows. But if we wanted to limit how many rows there are, or if we wanted to print more rows, we could use this head function. So df.head, say 2. Maybe I only want to print the first 2 rows. So that would be printing the first 2 rows. So that's printing the first 2 rows, and then you can also print, so it's just Frank and Sally. Maybe if you wanted to print the last 2 rows, you'd use tail instead. Um, there you go. There's different ways to sort these, which I actually forgot how to do, so I'm not going to teach that right now. So one of the things you can do is you can take this data frame, and you can subset it. You could basically take a certain chunk of this data frame and save it to a new data frame. So for example, what if I wanted to just see the people who are over 21, maybe the people who could drink. So I'm going to print df, and then in square brackets, I'm going to say df dot age is greater than or equal to 21. So this is sort of like some magic that Pandas allows us to do. Normally, if you're using regular Python, you wouldn't be able to do something like this. But because we're using Pandas and this is like a special object, it probably defines what this means in Pandas. So if we run this, oh, I see. So this prints the first 2, or 18 and 35, and then the second one prints just the ones that are over 21. Or you could do over 40 or something. That would just be one person, I guess, in my case. The other thing you can do is you can limit the number of columns that you have. So, I mean, 2 is already pretty small, but let's say you had, 20 columns here, and you only wanted like a certain, like maybe 4 of them or something, and you wanted to pick which 4 you could have. That would be pretty easy as well with Pandas. print df. I think that's how you do it. Let's see. Yeah. So what I did is this is a list of columns. Um, well, it's only got one element, which is interesting. So it's just got name right now. I could do both of them just to show you that this doesn't change here. Name and age. The other thing I could do is I could rearrange these things. So I could say age and then name, and this would just rearrange the order of the columns here. Oh, sorry, I have to save the file before I run it. There we go. So you'll notice here that it changed the order. So it says age and then name, like I did it this way. Let's say that we wanted to, I'm going to take this, just the names, and I'm going to save this to a variable called df underscore names. You'll notice that every time I do one of these things, it's not actually changing the original thing, the original df here. It's actually making a copy and printing the copy of that. And so when I do this, I'm selecting one column and assigning it to this other variable. This df names is a separate data frame that just has one column. But the original df still has all the data. So if I print df names, I just get the names. And then another thing I can do is I can store this as a CSV. So any sort of data frame you can output as a CSV. In that case, you want to do df.toCSV like this, and I'm just going to say names.csv. Just going to output the names. So it's still printed the same thing because we had these print statements. But what it did here is it actually created this file in the same directory that you can see on the left here. So I'm going to open this file. Wait a second. Oh, I screwed up. So I actually outputted the original df instead of df names here. I guess that was good because kind of demonstrated my point earlier. Df underscore names is what I wanted to print or output as CSV instead of the original df. Okay, so save that, rerun it. Okay, now it just has the name column along with this index. And actually, I think there's a way to get rid of this index as well. I'm just going to quick Google for this. Avoid printing index in Pandas to CSV. Oh yeah, index equals false. I actually could have guessed that, but I just Googled for it. Index false. Okay, so I'm going to rerun that. So now my CSV, yeah, my CSV doesn't have um, that first numbered field. Yeah, and you could also like say store this thing as like another one. Let's call this df drinking equals, and then you can do dot to CSV drinking.csv index false. Rerun it. So that's just the people that are 21 and over with their name and their age. Um, and you could, also, um, you could also select just certain columns. So you could say here, you could just say, I just want their name. Yeah, so now it's just the two people's names that are over 21. Even though the age doesn't show here, I selected it out before I removed that column. Um, yeah, I think that's basically all we covered. Um, like I said, if you have any questions, feel free to hit me up on email, kyle@kylemolka.com. Um, yeah, thanks. We'll see you on the other side.